Hi, Pre-Calculus Honors. So this is the last question to Notes 6.3, Day 1. Again, we'll do this last example here. Simulate horizontal motion. Okay, so we're going to use parametric equations and a grapher to simulate motion. And we're going to try and estimate the times when there was a change in direction. So we're going to consider a particle moving along a horizontal line where t, and we're going to think of t as time in seconds. Let's write that down, t in seconds. And we'll think of the coordinate with the coordinate of the particle in meters given by this particular equation. So again, we're thinking about horizontal motion. So if you grab your calculator right now and go ahead and go to mode, make sure you are still in parametric mode, go to y equals. For x, go ahead and type in the equation given here, and then we're going to let y, so let's say x equals negative 0.1 times t cubed minus 20 t squared plus 110 t minus 85. And for we're going to go ahead, I have two equations in my calculator, but I just typed it in advance. Let's let y equal 5. So 5 is actually quite arbitrary. Let's just say x1, y1. So I just chose a horizontal line to have the motion on that horizontal line, y equals 5. So 5 is quite arbitrary. So if we go to window, let's see, I just went from 0 to 12 because that's what that was given. We want to look at, again, to 12 seconds. And I made t-step 0.05 right now. That just seemed reasonable to me because, again, we didn't want it to be too slow or too fast. Now for x's, why don't you go ahead and just use maybe negative 11 to positive 11. And for y's, I just want to make sure that the horizontal line is in that window. So I just went from 0 to 10. Okay, so here goes. Again, when I typed mine in, notice I went back before the X, I hit enter here. I wanted to have that little baseball so that I could see it better. So when I went down here, I cursored right until I got the little baseball. But you don't have to do that if you don't want to. Okay, so let's take a look at the graph. So notice my particle is moving left, then it's moving right, and then it's moving left again. So again, we want to try and estimate, try and figure out when there's a change in direction. I mean, I guess there are a lot of ways we could do that. We could go back to window and make it move a little slower. Maybe we could trace. We could do things like that. That might work. Well, let's just try that, trace. Okay, so again, I think this might be kind of annoying though. If we, here, let me see. Trace. Okay, not working. Hold on. Trace. Oh, I'm going the wrong way. Sorry. Okay, so I have to go right because I want my t to go from 0 to 12. So there's t as 0.35, 0.45, etc. That was so funny. Okay, so notice it's still moving to the left. But remember what happened? At some point, do you remember it changed direction? So again, I'm using trace. I'm letting t go from 0 to 12. And if you remember, right around here somewhere, I thought it was when it started going the other way. Still going to the left. Now, let's see. Yeah, right around here. See how it started moving to the right? Approximately. It was approximately at 4, I think. And then it changed direction again over here somewhere. So there's got to be a better way. There's got to be a better way. So why don't we do this? Again, that first one, still moving. So our guess is approximately 4. And then if you remember somewhere, it moved again. We're just watching it with the trace here. I think right around here, somewhere around here is when it started. Again, let's see here. Still moving to the right. The particle is still moving to the right. I think it changed direction around here somewhere. That's quite, there you go. Yeah, right around there. So like right around 9.5 or something. Okay, but notice I went to y equals. Let's stop that. I went to y equals. And notice in this second, for a second set of parametric equations here, I didn't feel like typing this because I was quite lazy. So I went down to x2 and I went to vars, y vars, parametric, and notice I just did x1 because again I didn't feel like I was too lazy to type that again. And then this time I want the y to be t instead of 5. So notice the motion won't be horizontal. Watch what happens. This time, okay, did you see how I let y be t so it wasn't horizontal? But you see how it's a little bit easier to see where it changed direction? Here and here. Let's do that again. I'm going to go to y equals and trick it into graphing again. So I'll just type over it negative. There we go. Okay, so if you hit graph, let's see, I have baseballs going on. Very good. Okay, so my horizontal motion, so do you see how when it changes direction, then since there we go, that's where it changed direction, and then it's going to change direction again. Okay, so that might be a way to kind of help us. Let's go ahead and trace again. And this time I'm going to move the up arrow. And I will trace. So this is another way to kind of see when did it change direction. So I've got my t equals, remember we guessed it was approximately 4. Let's see here. Looks like it's at, let's see, 3.9. Yep. And then over here, and again, you could keep going. The other one was 9.5. But another thing you might want to do is look at the table. Okay, so again, you might want to look at the table. So if you go to table set, and we knew it was approximately 3.9, so maybe, I don't know, start at 3 or something, and our change in table 0.1, make sure these are both on auto. So if you go to table, notice you can see again, remember that y was quite arbitrary. Notice that our x is going from, it's negative 9.2, negative 9.3, so it's moving to the left, and then right about here at 3.9, do you see how we were at x equals negative 9.912, and then it was negative 9.9. So that's where it started moving to the right, and then negative 9.8, etc. So we know that at 3.9 seconds, we changed directions. And let's keep going because, again, we guessed the other one was approximately 9.5. So it might actually be quicker if we just go to table set and say start at, I don't know, 9. Oops, and then go to the table. So let's see, like right about here, do you see how it's negative 1.238, negative 1.238? And notice we were going negative 1.337, negative 1.289. So it's moving to the right, but then right about here, let's see, negative 1.337, negative 1.289, negative 1.256. Then right about here, 9.5. Notice now it seems to be going in the other direction. So right about t equals 9.5 seconds. Sorry, I think I explained that poorly. So notice like 9.1 is negative 9 is negative 1.4, then negative 1.37. So again, it's moving to the right, and then right about 9.5, there you go. Notice now these are more negative, so then it's moving to the left. So it changes direction again. So again, great job, everybody.